All right, today we're doing a deep dive into something pretty wild, the technical blueprint for a whole new kind of internet called the Semiotic Web. Now, this is all based on some fascinating documents that just came out from the Tokum Initiative. And let me tell you, this isn't just some minor update. We're talking about a complete reinvention of how our digital world understands truth and identity. So let's get into it. So, to really get why this new idea is so important, you first have to understand the problem it's trying to solve. And at its core, the argument is that our entire digital life, everything we do online, is built on a foundation that's, well, kind of creaky and outdated. It really hasn't changed much at all since the 90s. The biggest issue? We rely on all these separate, siloed databases. Just think about it for a second. Every link you click is a prayer that it hasn't broken. Data can be changed, and you'd never know. There's just no built-in way to know if what you're seeing is the real deal. It means we have no digital permanence, and that is a really shaky foundation to build a global system of knowledge on. And this question gets to the absolute heart of the matter. It's a huge philosophical shift. Right now, we assign arbitrary IDs to everything, like a product number in a store's database. This new system asks, what if we could discover a concept's true, mathematically certain address instead? This idea of Platonic discovery is pretty mind-bending, but here's a good way to think about it. It's kind of like the number pi. Pi just exists out there in the universe of math, right? We don't invent it, we just discover its digits. Well, the same principle applies here. The unique permanent address for, say, the concept of a dog already exists as a mathematical truth. Anyone or any AI anywhere in the world can run the math and arrive at the exact same address. No central company, no one is signing IDs. We're all just discovering the same fundamental truths. So that's the big idea. But how does it actually work? How do you use math to discover these universal truths? Let's break down the core components. Okay, the absolute bedrock of this whole system is something called the Canonical Comprehension Identity, or CCI. You can think of it as a permanent, unchangeable digital fingerprint for one single concept. How's it made? Well, you take a standardized name for that concept, like its official dictionary entry, and you run it through a cryptographic hash. That process basically turns the definition into a unique, fixed-length address that will always be the same. It's the system's fundamental atom of meaning. So if CCIs are the atoms, this is how you build molecules. You start with the CCI, the address for a single word. Then you can combine them to make bigger ideas. A CPI, or compound identity, links two concepts together, like saying dog has a tail. The I is the object, the tail in this case. And finally, the CTI, the contextualized identity, wraps it all up into a full statement with a source and a timestamp. Like, according to Wikipedia, on this date, a dog has a tail. It's like building sentences, but every single piece is mathematically guaranteed. Now, you can't just throw these atoms of meaning together any which way. They have to be organized into a very specific, mandatory structure. This is what allows it to become a navigable universe of knowledge. And that structure is called semantic space-time. Every single statement has to be categorized into one of these four dimensions. Let's stick with our dog example. A property of a golden retriever is that it is a dog. Its proximity would link it to a Labrador retriever. Sequence could map out its life from puppy to adult, and containment would show that it has fur. By forcing every piece of info into one of these boxes, the system avoids becoming a chaotic mess and instead becomes a structured, searchable map of all knowledge. But okay, the real world is messy, right? We have different languages, slang, photos, drawings. So how do you get from all that chaos to one of these super precise CCIs? Well, the system uses this resolution funnel. It starts by quickly checking what it already knows. If it can't find a match, it kicks it up to more powerful AI models that can really understand the nuance of language and images. The whole goal is just to sift through all that real-world ambiguity to find that one single mathematically certain identity for whatever you feed it. Okay, so we've got the atoms of meaning and the structure to organize them. Let's zoom out a bit and look at the big picture, the architecture of the network itself. The network is designed as what they call a holonic federation. At the very center, you have the CCC, the Central Concept Commons, which keeps track of the global consensus. That layer syncs up with SSSs, which are systems run by big institutions, think universities or corporations. And then, all the way at the edge, you have us, with our PPPs, personal privacy pods, on our own devices. This whole setup spreads out the workload so there are no bottlenecks, but everyone still stays in sync with the global truth. Now, this is where it gets really, really clever. The way this network handles security is a total game changer. Forget about usernames and passwords. Here, access control is baked right into the address of the data itself. It uses these secret keys called salts. And if you want to access private info, you need the right salt just to calculate its address. If you don't have a salt, you can't compute the address. It's not that the data is locked away from you. For all intents and purposes, for you, it doesn't even exist. So what's the point of all this? We've got a system for discovering truth with math, organizing it perfectly, and securing it in this revolutionary way. What does this new architecture actually let us do? Well, this slide really lays out the difference. Our current AI world is all about extraction. Platforms scrape up data, strip away who made it, and keep all the value. The semiotic web is designed for the exact opposite, cohesion. Because attribution is cryptographically baked into every piece of data, value can flow back to the people who actually created it. It completely flips the incentives. Suddenly, sharing knowledge is rewarded and hoarding it doesn't make sense anymore. And that's really the punchline. This system is designed so that a new, fairer knowledge economy isn't just a nice idea. It's technically inevitable. See, because every statement has a cryptographic record of who made it and when, questions like who owns this and how is this used are answered by the structure of the data itself. It's not up to some company's terms of service anymore. Here's how that would work. In this marketplace, anytime a piece of knowledge gets used, money flows. 70% goes to the publisher, 15% goes to run the system, but here's the kicker. The last 15% gets paid out as a quality bonus to everyone in the entire citation chain. That means if you made some foundational discovery 50 years ago, you get a little piece every single time someone builds on your work. It inherently rewards creating truthful, high-quality knowledge. So, all of this brings us to the big question, doesn't it? The blueprint is here. The logic seems to hold up. But is a web where truth is a mathematical property and everyone gets credit for their work, is that the actual future? Or is it a beautiful, utopian dream that's just too complex to ever become a reality? Ultimately, what the Tokum Initiative is proposing here is a truly radical vision. It's a world where the identity of an idea isn't something we just make up and argue about. It's something as fundamental, as permanent, and as discoverable as a constant in mathematics, a completely different foundation for everything we know.